We are given this second order differential equation, that is y double prime minus y prime minus 12y equals negative 60, with initial condition y of 0 equals 4, y prime of 0 equals negative 18. And we are also given the Laplace transform of y of t, that is y of s equals d over s plus a plus e over s minus p plus f over s. And we have to determine the constants a, b, d, e, and f. So let's see how to determine these constants. So first we consider the ordinary differential equation. So let me copy the minus y prime minus 12y, and this equals negative 60. So first I'm going to apply the Laplace transform to both sides. So I'm going to apply, I put this Laplace transform, and this equals Laplace transform of negative 60. Now we apply the linearity property of Laplace transform on the left side. So to do that, we have to apply the Laplace transform to each of the terms inside the bracket. So we get Laplace transform of y double prime minus Laplace transform of y prime uh, minus Laplace transform of 12y. And this equals Laplace transform of negative 60. So according to the property of Laplace transform, we can factor any constants out of the Laplace transform, and then if we factor the negative 60, we will be left with 1. So this becomes negative 60 times of Laplace transform of 1. Now I'm going to use these two formula so that we can simplify this. That is, Laplace transform of y double prime is given by this expression, and so I'm going to place that. So first I replace Laplace transform of y double prime by s squared times Laplace transform of y minus s of minus s times of y of 0 minus y prime of 0, y prime of 0. So I have replaced this Laplace transform of y double prime as the first three terms. Now I have negative of Laplace transform of y prime. So for that, I use this formula. So I have this negative. I put this negative and put a bracket. So Laplace transform of y prime is s times of Laplace transform of y. This is s times of Laplace transform of y minus y of 0. So this equals y of 0. And then finally, we have the third term, that is negative of Laplace transform of y. So this we can factor this negative 12 and then write down this as just Laplace transform of y. And this equals negative 60 times Laplace transform of 1. I just write down this as it is as of now. Now let's continue. We can use the initial conditions over here now. We know that the initial condition, that is y of 0 equals 4 and y prime of 0 equals negative 18. So wherever we have y of 0, we can replace this by positive 4, and y prime of 0, we can replace that by negative 18. So this we can replace as negative 18, and we have one more y of 0 here, so this will be replaced as positive 4. So let's simplify by substituting the initial condition. So this is s squared Laplace transform of y minus 4. This is 4, so 4 times of negative s, we will have negative 4s, and this is negative 18. We already have a negative here, so negative times of negative 18 is positive 18, and then we have this bracket, and we have s times of Laplace transform of y minus this is 4, so this can be written as 4. In fact, I can remove this bracket. When I do that, I will get this as s times of Laplace transform of y, and then this negative 4 will become positive 4. So I'm going to put positive 4 here. And finally, I have this last term, that is minus 12 times of Laplace transform of y, and this equals negative 60, and Laplace transform of 1 is 1 by s. I'm going to write down here. Now let's factor this Laplace transform like terms. We have one Laplace transform of y here, another one, and another one. So I'm going to factor this. So I will get Laplace transform of y, and then I put this bracket. So when I factor Laplace transform of y here, I'll be left with s squared, and here it is minus s, and the last term is negative 12. So we have taken care of these three terms, and then we have this negative 4s. So I put negative 4s. This positive 18 plus 4 is positive 22. So this equals a negative 60 over s. Now let's simplify. I'm going to add this term 4s as well as subtract this term 22 on both sides, so that I get only Laplace transform of y times of s squared minus s minus 12, and this equals negative 60 over s plus 4s minus 22. So now we are going to simplify this right side expression. The common denominator is s, and this means this can be written as 60 over s, and this will be, you have to multiply and divide by s, so it becomes 4s squared over s, and this has to be multiplied and divided by s, so it becomes negative 22s divided by s. Now we have the common denominator s, and so we just have to simply add these three terms. So first I put the 4s squared term, and then I put this negative 22s, and then finally the constant term, that is 60. And this is all over s. And this side we have Laplace transform of y. This I'm going to write down in factor form. It's a quadratic expression. We know that s squared minus s minus 12, this can be written as a product of linear terms, that is s minus 4 times s plus 3, because the two numbers multiplies to negative 12, and they add up to negative 1. Here we have negative 1. So these are the factors. So we can write down this as s minus 4 times of s plus 3. Now let's continue. Now I divide both sides of this equation by this expression, so that I will have only Laplace transform of y on the left side. So when I do that, I will have only Laplace transform of y, and this equals, I will have this fraction or the rational expression 4s squared minus 22s minus 60, and this when you divide, we have to multiply by these two terms, that is s times of s minus 4 times of s plus 3. So we can write down this Laplace transform of y. This is equal to y of s. So now we have the expression or the equation for y of s, which equals 4s squared minus 22s over s times of p. I will put this first. So I'm going to put this term s plus 3 first, then the s minus 4 next, and then multiplied with s. Now we have to rewrite this expression or this rational expression using partial fraction decomposition method. So let's do that. That is 4s squared minus 22s minus 60. This is all over s plus 3 times of s minus 4 times of s. This can be written in partial fraction decomposition as a over this is s plus 3 plus b over the next linear term, that is s minus 4, and then plus c over the last term s. Now we have to determine the constants a, b, and c. For that, I'm going to multiply both sides by the common denominator of the left side expression. That is, the common denominator is this complete expression. So when I do that, on the left side, I'll be left with only this expression in the numerator. So I will have 4s squared minus 22s minus 60, and this equals, when I multiply each of this rational expression, that is this expression as well as this expression as well as this rational expression, by this common denominator, that is s plus 3 times s minus 4 times s. Notice that we have this factor. There are some factors in each of the terms, so those factors will get cancelled. So for the first term, when I do the multiplication, this s plus 3 will get cancelled with this s plus 3 over here. So we have to multiply a with s minus 4 times s. And similarly, when you multiply the second term, this by this least common denominator, we notice that s minus 4 term will get cancelled, and so finally b will be multiplied with s plus 3 times of s, and finally c will be multiplied with the term which it does not have in the denominator. So this c will be multiplied with s plus 3 times of s minus 4. Now we can determine the values of A, B, and C by plugging in some random values for S. So first I'm going to plug in, that is put S equals negative 3. When you do that, notice that this term will get cancelled as well as this term, because negative 3 plus 3 is 0, and 0 times of S and B will be 0. So this term will get cancelled as well as the second term. So let's plug in s equal to negative 3. So therefore, on the left side, this will become 4 times of negative 3 quantity squared minus 22 times of negative 3 minus 60. And this equals 8 times of, I replace s by negative 3. So it becomes negative 3, negative 4 times of s, that is negative 3. So let's determine a by simplifying this both sides. So negative 3 squared is 9. 9 times of 4 is 36. And 22 times of 3 is 66. We have two negatives. So negative negative will become positive. So this becomes 66 minus 60. And this equals, this is negative 7 times of negative 3, which equals a positive 21. So we have 21a. So let's simplify the left side. This is 66 minus 60 is 6, and 6 plus 36 is 42. So we get 42 equals 21a. So divide both sides by 21, we get the value of a equals 42 divided by 21 equals 2. So we have determined the value of a, that is 2. Now let's see how to determine the other values b and c. For that, I'm going to plug in s equal to 4 on both sides. So when I plug in s equal to 4, this term will get cancelled, as well as this term will get cancelled, because we have the term s minus 4. So 4 minus 4 equals 0. And it will be left only with this expression for b. So on the left side, I plug in 4. So this becomes 4 times of 4 squared minus 22 times of 4 minus 60, and this equals b times of 4 plus 3 times of s is 4. So 4 square is 16, and 16 times 4 is 64, minus 22 times of 4 is 88, minus 60, and this equal 4 plus 3 is 7. 7 times 4 is 28, so this is 28b. Now this equals 64 minus 60 is a positive 4, and then 4 minus negative 4 minus 88 is negative 84. So this equals 28b, and this implies b equals negative 84 over 28, and this equals negative 3. So we found the value of b equals negative 3. Now let's determine the constant c. For that, I'm going to put s equal to 0 on both sides. So when I do that, this term will get cancelled, as well as this term will get cancelled. And on the left side, I will have 4 times of 0 squared minus 22 times of 0 minus 60, and this equals c times of 0 plus 3 times of 0 minus 4. So this gives, this is 0 and this is 0, negative 60, and this equals c times of 3 times of negative 4. 3 times of negative 4 is negative 12, times of c is negative 12c. So we get negative 60 equals negative 12c. So this implies we find the value of c equals negative 60 divided by negative 12, which equals 5. So we determine the value of c, which is 5. So now that we have determined the constants a, b, and c, we can substitute into the partial fraction decomposition. So therefore, this expression, this equals a by s plus 3, that is 2 by s plus 3, plus b, that is negative 3 divided by s minus 4, plus c by s, that is 5 over s. And we can also compare this with our original transform of y of t. So let's compare this. And when we do the comparison, we have s plus 3 here and we have s plus a here. So the d is the denominator. So we see that d equals 2 and a equals positive 3. And similarly, the next term is e, and this has to be negative 3. So e equals negative 3. And then we have s minus b. So here we have s minus 4. So b equals positive 4. And finally, this f equals 5. So this f equals 5. So we have determined the constants a, b, d, e, and f.